Hello. We'd like to welcome you to our 6th Open Science event. At PMI, we have a clear message to everyone. If you don't smoke, don't start. If you smoke, quit. If you don't quit, change. Nicotine, though addictive and not risk-free, is not the primary cause of smoking-related diseases. It's the harmful and potentially harmful chemicals generated by combustion of tobacco that leads to disease. And this is why it is essential to avoid combustion and smoke formation. But for adult smokers who would otherwise continue to smoke, products that still deliver nicotine increases the likelihood that they will switch to smoke-free alternatives. Therefore, the innovation of products that generate a nicotine-containing aerosol without tobacco combustion can provide adult smokers with a better alternative if they intend to continue smoking. With every new product that's developed, we need to accurately measure levels of harmful or potentially harmful chemicals. In addition, the characterization of the aerosol needs to be carried out to ensure that not only levels of these chemicals are reduced compared to cigarette smoke, but also that no new harmful compounds are formed. This is why the methods that we at PMI and others use to analyze these chemicals is so important. And this is what we will address in the latest Open Science event. 3 of our leading scientists will discuss the analysis of both targeted and untargeted screening of toxicants in the aerosols of smoke-free products and other alternatives. They will also discuss external publications that have touched on this issue. After this, there will be a live Q&A, and we invite you to ask us anything. Thank you for joining us for this conversation, and we look forward to your questions.
Good morning, good afternoon and good evening wherever you are, and welcome to this Open Science short session. We're trying a little bit of different format this time, recognising that we're all a bit fatigued sitting behind a screen, so we're going to keep it short and hopefully sweet. We're recording the session, and of course, as mentioned in the video, you have an opportunity to ask questions whether you're watching on LinkedIn or through our Open Science platform. So I want to also give a very warm welcome to our expert guests today. I have Dr. Catherine Goujon, who's an expert in analytical chemistry, and Dr. Maurice Smith, who's our expert in toxicology. And I think between both of them, they have really a wealth of experience in both designing and conducting studies, but also reviewing the literature that's out there in relation to the analysis of the aerosol of smoke-free alternatives. We recognise there are many challenges and pitfalls in doing this. I think we've all experienced that. And I think it would be a good opportunity for us to discuss those openly today. So first of all, Catherine, turning to you. So analytical chemistry really is part of the foundation of our overall assessment programme, and with any foundation, it has to be as strong as possible. So what, from your perspective as an analytical chemistry expert, is really the single most important thing that you want to think about when you're designing a study for smoke-free products?
There are many important things, Maura, and I will have difficulty to select only one, so if you don't mind, I think I will go for 2. And I will bridge the first one with the opening video we had. I think the aerosol generation is an important one, because the aerosol we produce should represent what the user will inhale. So we need to make sure that we generate properly this sample, and for that, you saw we have a linear smoking machine. We use standards. So would be for me an important criteria, otherwise you go to misleading results, whatever technology we use. And the second important thing I would highlight is a good comparator. And for any analysis we conduct, any study, we use a reference cigarette, which is produced by the University of Kentucky, and it's used in any testing laboratory worldwide for the analysis of tobacco products. It's a not commercial product, it's an unflavored cigarette, but it really helps us to make sure that if we compare the level of toxicants within the THS aerosol compared to smoke, or if we have any compounds new in our aerosol compared to cigarette smoke. Right. So this would be the two I would name.
Okay, so firstly, making sure you're generating the aerosol in the correct way so it's reflective of what might happen in real life. And secondly, comparing it to something which is known and standard so that you can have comparable results, I guess, is what you're saying. Okay. Yep. Now, you and your team have really focused on two main types of assessment, and we call them targeted and untargeted analysis. So maybe you can explain for the audience what do those terms mean?
So targeted, we know what we are looking for. It's specific chemical-specific HPHs, and this list of HPHs is provided by regulatory agency. So we know what we are looking for, and those methods are validated. We are using them routinely in our laboratories, and they provide quantitative results. On the other side, and I would say what answer to this question with untargeted is the level of reduction of THS aerosol compared to cigarette smoke, so where we have a number of reduction of 90 to 95% reduction of emission, it's using those targeted methods. Mm-hmm. On the other side, untargeted is looking at what we don't know. And the key questions behind untargeted is really to identify if there is any additional unknown harmful constituents in our aerosol. Mm. And to do that, so it's not specific at all. We are really searching, and we are categorizing the aerosol in two ways. One way will be to look at a full characterization above a certain threshold, a cutoff limit. And the second purpose is also to look at differences compared to a reference, which is the reference cigarette we use, to look if there is any new compounds or if there are harmful constituents increasing in THS aerosol compared to a cigarette. Mm-hmm.
Okay, so targeted is really looking at sort of known compounds and understanding quantitatively what levels are there compared to the reference cigarette smoke. And untargeted is really like shining a searchlight almost over the aerosol to figure out what else might be there, and then giving us an idea of generally what level there might be. Is that sort of more or less in layman's terms?
It's correct. It's giving also a good estimation of concentration of the analyte in the aerosol as well.
Mm. And I know that you've published a lot of this, and I think most of that, if not all of that analysis, is available, for example, in our modified risk tobacco product application on FDA's website. So I think if people are interested in the methodology that they've used, that would be a good place to go, and perhaps we can put that in the chat, in the Q&A chat, so people can go and find out more if they want to. So now turning to you, Maurice, as a toxicologist, you get the data from Catherine's reports and look at it from your perspective. And I know that you're particularly interested, for example, in what we call the PMI 58 list. Can you explain why that's important and what it is?
Yes, that's the list that we've routinely used and reported, but it's not us misleading just to call it a PMI list. It's much more a composite list from other agencies. So as the history of smoke analysis has grown, then the number of lists have grown. So we've seen lists from Health Canada, from WHO, from IARC in terms of carcinogens, and also from FDA. Mm. And we've incorporated those into our list, not the full FDA 93, but we can talk about that afterwards if necessary. But we have an extensive list of those compounds which are considered by international agencies to be most important in terms of causing smoking-related disease. Mm. So if we measure those routinely and we can see a reduction with our new products compared to cigarettes, then we're pretty confident we're going to see not only reduction in exposure, but also ultimately reduction in risk. But of course, proving that is the difficult part.
Right, and that's why we have, a broader assessment program that goes beyond the expertise that you have.
Exactly.
Okay. When we first started creating our assessment approach for smoke-free products, there was not really much in the way of reference material that we could use. There was no sort of path that we could follow, because we were really ultimately almost the first really to go into this area of science in the detail that we did. So we kind of had to figure things out as we progress. But now, fast forwarding to 2022, I understand there are a number of sort of guidances and standards that are available that can help to guide people when setting up their own assessments. So could you talk a little bit about what guidance you're looking at?
Yes, a little bit, obviously, to keep it short. But I mean, when we started, as you say, there wasn't a Bible to work to. So we had to think about it very carefully. I think one of the breakthrough moments was looking to see, well, we compare with cigarette smoke, which is very important. But if we can show that in our exposure studies that we see levels of exposure approaching that of quitting cigarette smoking altogether, then that's a very powerful measure as well. So we have those sort of two goalposts, if you like, to work between. But so that was a sort of breakthrough moment. But then, of course, we had to then establish a whole sort of stepwise approach that starts from analytical chemistry, as Catherine's explained, going through toxicology, going through clinical studies, going through perception and behavior studies, to see how people use the product, because that's key, and then ultimately doing longitudinal sort of epidemiological type studies. So in terms of guidance, then I think an important step for us was to see in 2012 the book from the Institute of Medicine looking at scientific standards for assessment of MRTPs. And we were sort of gratified to see that our assessment plan was very similar to what they were proposing. And then, of course, since then, there have been various guidance and draft guidances from the FDA, because that's the agency most advanced in terms of thinking in this area. And so there's draft guidance on assessment of products for an MRTP, a modified risk tobacco product application, also for a multi-product application as well. So those are the basic guidances, but then Catherine may say some more about specific guidances on the analytical side.
Catherine, what guidance are you looking to and your team are looking to?
For targeted analysis, that definitely the FDA guidance that Maurice mentioned is very well structured, and you can really follow the requirements that will help to have the most accurate method you want. Because the challenge we have with the THS aerosol is that the level of constituents we look at very low level. So meaning that we have a variability in the measurement if we don't not apply the appropriate requirement. Another norm that we follow is the ISO 17025, and we have our targeted analysis lab accredited, and it gives you a QMS environment to make sure that you provide accurate results. And part of this norm, it's required to have interlaboratory tests, so on the reference cigarette, but also on the product we develop, and it's to make sure that the method we have in place are properly set and accurate and providing the right results.
So you mentioned QMS, maybe for people that don't know what that acronym is, that's Quality Management System. So maybe just briefly, both of you, why is having a quality management system in place so important? Catherine?
I think it's what I would call good practices, but you need to make sure that your equipment is running properly, so there are suitability tests. You need to make sure that your method is fit for purpose. You need to make sure that your resources are trained to run this method, so there are many elements to make sure that at the end of the day, the results we publish are the right one and are not challenged.
And for you, Maurice, a quality management system, what does it bring to the toxicologist?
I think it's key. I mean, there's skepticism about research coming from the tobacco industry, so therefore we have to operate to the highest transparent standards. So not only do we have a quality management system, we operate to good laboratory practice, good clinical practice in our clinical studies, for example. So that allows external auditors to come in, look at the results, to build up, the study results starting from the protocol to make sure that we're doing everything to the highest possible standard. So that underpins our whole approach, really, that we have to be not only adopt the highest standards, we have to be transparent and be able to demonstrate that. Yeah.
Right, very good. And part of all of our jobs is reviewing the scientific literature as well, and we're reading papers every day. I wonder, Catherine, what are the things that you read in independent studies that sometimes you think, there's something missing, something has been omitted or not well described? What are the most important things that you see from the literature that are oftentimes not to the standard that you would prefer to see?
If I consider targeted analysis, and I think a statistician will love my answer, it's no compromise on the design of experiments. Again, number of replicates is something that sometimes we see experiments done on 1 or 2 replicates. And again, as we are looking at very low level, it's very important to not compromise, for example, on this. Otherwise, you will have a variability that at the end of the day, you won't be able to compare your products. So that's for the targeted. For the untargeted approach, what I see the most is misleading in the compounds identification. And to us, we mentioned compound identification when we have a confirmation of the structure by an injection of an authentic reference standard. Because otherwise, if you come with a wrong structure with a wrong codification, then the toxicologists, they cannot just do their job. And it's really where we see some misleading or partial identification step, not properly described. And this is sometimes where we have some wrong conclusion in the articles.
Okay, so number one, having the experimental design locked down and well described, I think we would all agree that that's important.
To answer the research question at the end of the day.
Right, very good. And Maurice, on the other side, we also see some really great studies out there. So when you open up your computer and have a look at what's been published in the morning, what sort of makes you happy to see in terms of quality?
And again, I think it's looking at the overall flow of the logic from the initial problem formulation. So what are they trying to assess, to then looking at the methods, and then obviously finally looking at the results. And if they all sort of tie in, and you can trace exactly what they've done, that allows us to then compare their results with what we obtain, and obviously, if there's close agreement, then that's great, but that's not always the case, of course, and then we have to understand why there are those differences, and that's how we learn and develop and improve our own system. So I think there are a number of excellent publications where you can go back and you can do exactly that process and be confident that everything is in good shape. There are, of course, examples where that hasn't been the case, and I think it's important to then have that dialogue to point out. So there have been examples of locally where our products have been analysed, the results have been surprising, we don't understand. We've then gone back and can understand exactly where the problem was, but those publications remain. In the public domain. Every time somebody does a systematic research, they pop up again, and we end up answering the same points. And even FDA, when they looked at this particular study's data, confirmed that the analytical methods were not robust enough to substantiate the results. So it's frustrating when that happens, understandable, because as we've seen, the equipment is expensive, the expertise takes many years to build up. But the combination is important, and if you don't have that, then of course you can lead to an unsatisfactory publication as well.
Right, and I think I look at it not just from the scientific perspective, but also how these things are reported on in the media, and I think we're all very sensitive to ensure that the general public and adult smokers get accurate information. So the reporting on scientific studies becomes extremely important. Okay, just before we go to the questions that have been submitted, just a last couple for one for for each of you. So Catherine, you sort of set up laboratories here in this fantastic building. We're fortunate enough to have the resources to be able to buy the best equipment and run, I think, really well-designed studies. But if somebody in the audience is slightly less fortunate, is you know, thinking about setting up an experiment or a lab, what would be your sort of one key piece of advice to them?
I think literature review or scientific articles is a good source of information, and it's very important to have a critical but fair eye on the publication. Then keeping a common sense on what makes sense to establish and why, I think it's really something that need to stay as any scientist, and whatever the budget you have to implement your capability. And being exposed to other scientists, in conferences, in scientific forum, is also important, because it's also from others that you get good ideas to progress. And this is also something that we commonly do.
Mm. And you, Maurice, what would be your recommendation?
I mean, from a toxicological perspective, it's really then about being clear about the levels of exposure to the various constituents in the aerosol, to make sure that they are realistic, you know, they're relevant for human exposure, and you can then start to interpret the results for human use of these products. So I think it's, you know, it's common sense, but it's not always the case. Sometimes people use heroic doses of aerosol, and not surprising, you saturate systems and you get results which just aren't interpretable. Right.
Okay, thank you. So now I'll move to some of the submitted questions. There's a lot already. So I'll take the one that's at the top here. I think this was submitted through the Open Science platform. And perhaps this, maybe Maurice, you could address this. So how does the chemical composition of PMI's heated tobacco product, IQOS, compare to that of other marketed heated tobacco products? And if there are any major differences, how can they be explained?
Yes, I think to start with, once it's been established that the other products also don't combust tobacco, then you can see what that means in terms of the aerosol composition. So there have been certain analysis where other companies have used our product as a standard to compare against, and able to show both that our results were appropriate, but also their product is very close to ours. So there will certainly be some differences, different product design, different heat stick design, whatever that is, different ingredients in the tobacco product. So we expect to see some differences, but I think what we've seen are much greater similarities than differences. So it's the absence of combustion that makes the difference. And,
right.
Once you demonstrate that, then there are certain consequences of that, and that's all on the good side.
Right, very good, thank you. And this one from LinkedIn, I think, Catherine, you would be the best person to answer this. So the question is, are there any reference standards for e-cigarettes or heated tobacco products in the same way as you mentioned for cigarettes?
To my knowledge, as 3R4F or reference cigarette produced by the University of Kentucky, no, but internally we are using what we call monitor, and it's really monitor for each category platform. So we have one for tobacco heated systems that really follow all the method development, validation, and also again the assessment we conduct. And for the e-cigarette, we always use what we call a base liquid, which is composed of PG, glycerin, and nicotine, also as a blank, let's say. I don't know, Maurice, if you have any.
There was some work in the States on a reference e-cigarette. And to be honest, I don't know where that ended up, but I know there were discussions about that, and I'm not sure if that's used widely, but there is certainly some literature out there on that reference product.
And I think it's part of the ISO accountability also, and Coresta accountability to put in place those standards. So I'm pretty sure that they are work in progress.
Right, so I think it's something that absolutely we would welcome, because I think it helps to give clarity for everybody who's working in this area if everybody's working with a standard product to compare to.
And this category product.
Yeah. Okay, Catherine, there's another one probably for you from the Open Science platform. Are the chemicals in the aerosol of PMI's IQOS fully identified and quantified?
That's short questions, but I think the answer might be a bit longer.
Okay.
So, as I described previously, we use untargeted platform to characterize aerosol above a certain threshold. And what I can say is that above a threshold of 100 nanogram, we were able to identify and quantify approximately 500 constituents. All those constituents were also found in the 3R4F cigarette smoke. So nothing new, but at level far below the 3R4F cigarette for most of them. And if I have to provide some number, 96% of the total mass of the THS aerosol has been identified by authentic reference standards and quantified. Now accurate quantification is key when we detect harmful and potentially harmful constituents, and when the toxicologists need to have a proper level of concentration to make their opinion about the level. So fully quantification based on the untargeted platform, yes, but exact quantification with targeted is when it's on purpose.
Okay, very good. So pretty well characterized, I think.
I think so. 96%. I think so. I think it's the most comprehensive characterization of the aerosol ever conducted.
Very good, thank you. And here's one for you, Maurice, again, I think coming from Open Science platform. Could there be chemicals in a smoke-free product's aerosol that are not detected by any of these untargeted analysis methods that are of toxicological concern?
Well, yes, because of the complexity, but we do two things. I mean, one is, as Catherine's explained, certainly in our product, we've got a very detailed and pretty comprehensive assessment of what's in the aerosol. But we don't stop there. I mean, we also do toxicological assessments, so we screen it through various in vitro, in vivo, and also because of the excellent teams we have here, we can also look at the systems, the impact on systems, on adverse outcome pathways to see whether we're triggering certain key stages that could lead to disease. So we do a pretty comprehensive assessment of the tox, which builds on the analytical side of things. So we're pretty confident that if there is something there, that it's not of toxicological concern. Because of the toxicological examination, but also where compounds are identified, then we can look at the toxicological profile of those constituents and look at the levels that they occur, which is often extremely low, nanograms or picograms, and we can be confident that they're not going to pose a toxicological concern.
Right. So I think that's a perfect example of why, although analytical chemistry is the foundation, it's not where we end in terms of our assessment approach. There are many other layers that help to build the confidence in the evidence overall.
Exactly.
Yeah. Okay, maybe this one for you, Catherine. How is PMI engaging with the scientific community to have its newly developed analytical methods being established as international or national standards for smoke-free product assessment?
So there, for targeted analysis, there are now working group in place. Again, I was mentioning ISO, I was mentioning Coresta, and it's really working group of different companies on the academic also worlds, connecting together to put in place for those standards. For untargeted, it's a bit more complex because the technology as such is extremely complex. To conduct an untargeted assessment internally, we have 7 methods, so you need to have the state-of-the-art equipment. All the processing part is something that also we design, and it's not commercially available, so it's difficult to have a standard for the untargeted. Nevertheless, there are requirements, there are discussion also with scientists, and we are working with analytical chemists conducting untargeted analysis, maybe not on tobacco, but also on different matrices. And this is I would say, the improvement of the method and the standards in place.
Very good. Here's another one then for you, Maurice. Which lists from the various regulatory authorities do you take into consideration for your targeted analysis? Now, you touched on this a little bit, but maybe just repeat what are the most important lists we're looking at?
Well, it's really all of the lists I mentioned before. So, the WHO contribution, Health Canada, FDA, also compounds taken from the IARC, National Agency for Research on Cancer list of carcinogens. So those form the list. But I mean, it's interesting now that to look at, and there are a number of papers that have come out from Holland and from other scientists looking at which compounds actually exert the most effect in terms of smoking-related disease. So if you look at carcinogens, then you can look at cumulative exposure to some of these compounds. So it's the lists are there, but it's dynamic, and then we always have to go beyond those lists to turn them into something which is useful for risk assessment and to begin to interpret what the impact of people switching, adult smokers switching to these products, could have on their disease risk. So I mean, it's an evolving process, I think.
Okay, here's another one. It's quite a complex one coming from LinkedIn, maybe to you, Catherine. Does PMI have data that examines the difference in aerosol toxicity as the function of the relative proportion of free-base nicotine in the aerosol and the distribution of this species in gas and liquid phases? So actually, it's probably for both of you. I'll start with you, Catherine. Yeah. Quite long.
I heard toxicity, so definitely a part of the answer should be for Maurice.
Again, free-base nicotine and the distribution between the gas and liquid phases.
So what I can answer to this question, I think it's our duty to understand the aerosol we produce with our reduced risk product. And in that sense, it's research areas that we conduct to understand the composition of the aerosol, the particle distribution, because it's important to make sure that the nicotine is properly delivered into the lung, and there are some particle size that are critical, and of course the composition of this particle size is something that we assess in our research projects.
Okay, good. And Maurice, the free-base nicotine, what's the toxicological impact?
Yeah, I mean, you've got a couple of nitrogen atoms in the nicotine and some free electrons, so they can be protonated. It's only the monoprotonated form that really exists at physiological pH. So we know that there are some differences then in how it distributes between the aerosol and the gas vapor phase and the particulate, the liquid particles in the tobacco heating system. So, how you would normally do that is to look at the pH of the environment of the aerosol. But measuring the pH of an aerosol, that's not really, or smoke, is actually very difficult. So recently there was more recently there was a publication from Vienna Trash where they've used NMR to look at the protonation state. And they looked at that in the tobacco heating system aerosol and saw that it was almost completely protonated. Now, protonation can mean different things, depending upon. Many years ago, there was concern that it was the free base form that was much more readily absorbed. There's now concern, because of using nicotine salts, that makes the nicotine somehow less harsh and therefore more likely to be absorbed because you can inhale it more deeply. It's a combination of those things, but I mean, what really matters is that when nicotine in protonated or unprotonated form is absorbed enters the lung, it's rapidly and effectively absorbed in either state. It may reach different parts of the lung, but it is well absorbed, and so it doesn't impact on the overall toxicity of the smoke, because it's not the nicotine that's the major cause of toxicity, of course.
Right. Very good. Thank you. And we're about 5 minutes over, but maybe just one or two more questions, if you don't mind. So the first one I think I could answer, but I'm going to hand it to you, Maurice. Is IQOS a validated tool for cessation?
Yeah, I'd like to bounce that back to you as a pharmacist as well, but I'll have a go. So no, I mean, it's not a cessation aid. It's a consumer product for adult smokers who would otherwise continue to smoke, to be able to switch to and therefore transition away from cigarettes. If you talk about a smoking cessation aid, then that's a medicinal product. You have to go through a whole new process there to get it registered as such, and that's not the route that we've chosen to go at the moment. I don't know whether you want to add to that, but
I fully agree. And maybe just one last one. I know there are questions about all sorts of different topics. I try and keep it focused on the topic that we had today. So when do you expect regulation focusing on the chemical composition of electronic cigarette aerosols to be released? Regulation. I think maybe I'll rephrase it. Standards is perhaps an easier way to describe it. Do we expect that countries will be setting standards for example, the content of e-liquids, or standards for the content of emissions? Do we see any developments there, Maurice?
Yeah, I mean, there's a lot of discussions. I mean, of course, with the pre-market tobacco applications on e-cigarettes in the US, then already you're starting to see an approach which can lead to PMT approval. So that gives us some ideas, but of course we have the Tobacco Products Directive, which gives us some markers there as well in terms of regulation. But it's evolving, I think. There's lots of discussion in the area, but I think it will be sooner rather than later. But it's important that the various experts are involved in that to come up with reasonable regulations which, encourage smokers to move towards using e-cigarettes or other products and move away from using cigarettes. So the regulations would help them to do that and not put barriers in their way, I think.
A difference between tobacco heated system and e-cigarette is that in e-cigarette, the composition is nicotine, PG, glycerin, and flavors. And I think, yes, in the scope of regulation of flavors, again, it's a lot of work in progress, and it will be, I think, really good things to have something crystallized and standardized. It will help also to make sure that we deliver also flavors on a not harmful way.
Perfect. Well, thank you both very much for spending the time today to share your thoughts. Really appreciate it. And thank you everybody who joined on LinkedIn as well as our Open Science platform. We have lots of questions. We haven't been able to answer them all, but we will be looking at them and we'll be using those as inspiration for the next Open Science. You can also answer our survey as well, and you can give us ideas about what you would like to hear us talk about at the next session. In the meantime, thank you again for joining, and have a good rest of your day. Bye-bye.